Okay, we're going to be looking at mathematical modeling today with functions. And we're going to start off by looking at relations, which is a set of ordered pairs. And there are several ways that we can write relations. We can write them in set notation with ordered pairs. We could draw a mapping. We can have a table, a graph, or an equation. Now, these first three things here, the ordered pairs, the mapping, and this table, all represent the same relation. The 8 is mapped to -1 in all three of these relations, and the same for the other set of ordered pairs as well. In these last two examples, this graph and this equation are representing the same relation. So what we're going to be doing is looking at specific relations called functions. And we're going to start off by looking at just what a model is. A model is a way to represent a real relationships, and it helps us understand it. It is based on relationships between quantities that can change. And that's key here. It's based on quantities, which means sets of numbers. You have to have two sets of numbers that you are relating. Mathematical models are described by one or more mathematical tools called functions. Okay, a function describes how a dependent variable changes with respect to one or more independent variables, and we're going to see several of examples of this in a minute. The variables are quantities that change or vary, and for each independent variable, there is exactly one dependent variable. Now, one thing you need to know is that not all relationships are functions. So we're only going to be working with functions in this chapter. There are three basic ways to represent a function, either with a table, a graph, or an equation. And we're going to spend most of our time looking at graphs and equations. We looked at tables in section 8A, and while those are useful sometimes, it's sometimes easier to see the relationship with a graph, and sometimes it's a lot quicker to figure out what that relationship is going to predict if we use equations. So let's talk about functions in general. For every input, there is exactly one output. As you can see here, I have a table of values, and my x values are called the domain. Those are also called the input values or the independent variable. The y is my dependent variable, which means my y values depend on the x, and those y values are also called the range or the output values. Okay, the directions here say, can the following situations be described using a function? If so, identify the independent and the dependent variables. Okay, you jump from an airplane with a parachute, and you want to know how far you have traveled at various times during your descent. Well, remember that functions have to describe two sets of numbers. So do I have two sets of numbers here? Well, yes. Times is obviously a number, and how far is a distance, and that is a number. So I do have two sets of numbers. So I need to identify the independent and the dependent variable. When identifying the independent and dependent variable, I think sometimes it helps to actually identify the dependent variable first. Which variable depends on the other? Does the time that you've spent on your descent depend on how far you've gone, or does how far you have gone depend on how long it's been since you've jumped out of the airplane? Well, your distance that you have fallen depends on the time that you've been in the air since you've jumped. So my dependent variable is my distance, and the independent variable is time. Okay, problem 2. Karen recorded the number of gallons of water used each month and her monthly water bill. Do I have two sets of numbers? Well, number of gallons of water is obviously one set. Do I have another set of numbers? Well, it doesn't really come right out and say that, but her monthly water bill is money, and that is definitely a set of numbers. So I have to identify the independent and the dependent variable. Okay, so which one of these variables depends on the other? Does the number of gallons depend on her bill, or does her bill depend on the number of gallons that she used? Well, her bill is going to depend on the number of gallons. So my independent variable is the gallons of water used. And my dependent variable, remember, it has to be numbers. So it is the amount of money owed. All right. And my next example says you compare a person's age and their hair color. Well, remember, when we're looking at functions, we want to be sure that we have two sets of numbers that we're looking at and see if there's a relationship that we can connect between those two sets of numbers. Well, a person's age is obviously a number, but hair color is not a set of numbers, so I cannot create a function using this information. Question: what real-life experiences or situations can you think of that use the concept of functions? And then see if you can think about that and identify the independent and dependent variables. So you might want to pause here and see if you can come up with something on your own. One real-life example that I can come up with right off the top of my head is dealing with the paycheck. For hourly workers, the more hours you work, the more money that you get. Okay, the directions for my next set of problems says to write a short statement that expresses a possible relationship between the two variables. We're going to be looking at these two variables, in this case, elevation on a mountain and temperature. The first value here is always your independent variable, and the second value is always your dependent variable. So here we want a relationship that's going to represent the relation between the elevation on a mountain and the temperature. So what happens to the temperature in relation to the elevation? Right, the higher up on the mountain you go, the colder that it gets. Okay, the higher the elevation, the lower the temperature. Now we're going to compare hours driving and gas in the tank. So pause the video and see if you can figure out that answer on your own. The more hours driven, the less gas in the tank. All right, now we're going to go on to look at some graphs of relations. And the first problem I have here says, the title of my graph is John's exercising routine. Warm up plus the jogging. Horizontal axis is the minutes spent jogging, and the vertical axis is the total calories burned. And I need to identify each of the following: the independent variable and the dependent variable. Let's start with just those two. The independent variable is always going to be the horizontal axis. Your dependent variable is always going to be your vertical axis. Okay, the next thing I want to do is find the minimum domain value. And again, the domain are the x values are along the horizontal axis. So the minimum value there at this point is 0. The maximum value of my domain is how far to the right I go, which is this point, and the corresponding x value there is 40. Okay, my next two questions ask for the minimum and the maximum range values. So that's still these same 2 points that I have highlighted in green here and here. But now I want to be looking at their corresponding y values, which I can find by going over to the y-axis here at 450 and right here at 50. So those are my minimum and maximum values. And then the last question there is to describe the relationship shown. So we can see here that we're representing the minutes jogging and total calories burned. So the more minutes John jogs, the more calories he burns. Okay, I want to go back up and look at the graph once more. And let me clear some of this stuff off here. And what I want you to think about now is, why does my graph start at 50? I mean, it makes sense that if he spent 0 minutes jogging, that he would spend 0 calories burned. So why does it start at 50? So let me give you a minute to pause the video and think about that. To understand why your graph starts at 50, you have to go back to the title of your graph. It says warm up plus jogging. This 50 calories burned is the calories burned from the warm up. Okay, the next graph says Josh's car trip. And the horizontal axis is the time in hours, and the vertical axis is the number of miles from John's home. So the first thing we need to do is identify the independent and dependent variable, and then we're also going to find the minimum and the maximum values for my domain and range, and we're going to describe the relationship shown. So I want you to pause the video and see if you can figure all of that out on your own. Okay, let's look at these answers. The independent variable is time in hours. The dependent variable is the number of miles. The minimum value for the domain is 0, so it's as far left as your graph goes. The maximum value of the domain is far right as your graph goes, which is 4. The range is like from bottom to top, so from 0 to 160. And the description of the relationship shown. Now, I said for every hour, the number of miles from home decreases by 40. So that was kind of detailed, and it gets into rate of change, which is in our next lesson. A little bit more real-world way to say this is that John's getting closer and closer to home.